this thing to... There we go, focus. Welcome back to the channel, guys. So today, it's a very cold morning. I've been tasked with changing 3 sockets across 2 3-phase EV chargers. So quite a simple job, but we'll be able to take them apart. They're Rolex chargers, pillars. So yeah, that should be pretty cool. And I've also got the new QTech EV SE adapter. So we'll be able to run through the full sequence of tests, show you guys that, and also check out this new cool bit of kit. So yeah, it's a cold one, but it should be a good one. Let's run the intro. So this is the Q EVSE adapter. I've got my KT66 as well in there, but this is basically going to do all of our testing. So yeah, you've got the PE pre-test to make sure that there's no hazardous touch voltages on the earthing of the charger. Then you've got all your states or your current ratings, so open 13 amp, 20 amp, 32, 63. These ones are all 32 amps, so that'll be pretty straightforward. And then we got our CP states as well. So A is open, B is on but not charging, C is charging without a fan for chargers with no fans, and then D is charging with a fan for chargers that do have cooling. You can also have the CP error state E and the PE error for your functional tests. This will also provide like signal outputs. I was just looking at the instructions. I don't know a lot about EV charging, to be honest. I haven't even done the course, but this will send out a signal to a bit of kit and provide a waveform, so you can analyze the waveform. It's pretty crazy. You've got these terminals on the front, so that's how you can do the different phases for 3-phase. It's also got a socket on the back that will just connect to L1 basically, so that will do all your normal single phase chargers. And then yeah, it does phase rotation as well, does all sorts, so that'll be pretty cool to show this in use, have some fun with that. Speaking of the chargers, it's these Rolex EVs. So decent chargers. I need to look at these. I know they're quite old. Yeah, we need to assess and make sure that we've got, the correct RCD protection. Maybe they're rodded, I don't know. There's lightning protection there, so there may well be earth rods for these as well. But the reason why I'm changing them is because if you can see in there, the pin, that one there, I'm not sure what that one is, maybe L1 or I'm not sure. It's burnt out on this one, and on one of those ones as well. What it is basically someone's been connecting a Polestar EV up. Nothing wrong with the Polestar, but their lead was dodgy basically. It had plastic missing, it was just a loose connection on the pin, and it's just been arcing away, where they're just unknowledgeable basically. They've realised now it's the lead that's the problem, they've sorted that out, and now we're just here to sort out these sockets so that they can be used normally. I'll go get some tools out, get the sockets out, and we'll start changing them together. Right, got myself a hot chocolate. Get me warmed up a bit. It's absolutely freezing today. This is an Allen key, I believe. Get this apart, yeah. That'll do. So I've already isolated it. I can't show you that because of client privacy, but I have the keys here. You're also locked off on a tripod, and there's no dynamic shots today, I'm afraid. The cameraman is at home. He's actually at load out, he's got plenty to do there. That's one of the reasons. The other reason is I just fancy doing a proper vlog like I used to. It used to just be me and a GoPro on site, sharing my day to day. And while I love the new camera and the image it produces, I'm certainly not going back to a GoPro, no way. It used to just be Mike with a camera on the tools, and some of the videos have got quite, not real, but B-roll, set pieces, fancy sequences, which I'm not saying is not going to happen, but I just wanted to switch it up and do what I used to do. Let's get the cover for this, get that turned around. Interesting. Before we do anything, let's prove dead. What are these doing? They're lighting up, but they're not making a noise. There we go. Let's a bit weird. Let's just do that again. Cool, clear, clear, clear. Okay. Yeah, don't know what happened there, but we are dead. So now I can bring you in and show you some of this damage. So you can see here that cable's, yeah, got some serious heat damage to it. This one down here is the same. If I move that out the way. So yeah, they've definitely got very, very hot. I'll have to trim them back, referrule them, make those connections good. Yeah, apart from that, it should be pretty straightforward. Let's talk about this though, because this is interesting. And while I don't know a lot about EV chargers, to be honest with you, I haven't done the course. I've installed a couple, tested a couple, but I'm in no way an expert on it. I know enough about these gubbins to talk you through it. We've got our cable coming in, our feed coming in single phase. I think I said in the intro as well that these were three phase, and while they have the ability to be three phase, when you look at them at face value, the circuit references when I isolated them and everything, it was made abundantly clear to me that they are only single phase, which is fine. I'm just here to change the sockets regardless of that. But yeah, I did say they were three phase, but it turns out they're not. I just thought these sort of pillars in this sort of location, I just thought they'd be three phase. Now basically your feed comes in here, goes through the RCD, goes through the contactor and ends up at the socket. That's just how it works. The RCD is obviously monitoring for leakage, and then the controller is checking for charge states off of the pilot, and it's also connected to these DC residual current monitoring devices, which have a input off of the controller, an A1 in and then an A1 out, which actually controls the contactor. So if that isn't happy with DC current leaking, this won't let through, the contactor won't be energized. So not only have you got this upfront type A, you know, AC and DC RCD protection here, you've also got residual current, DC residual current monitoring modules that will control the contactors too and cut them off regardless of the state that the RCD's in. So yeah, lots going on, loads of fancy kit. This looks like it's had an upgrade as well, because they got different stickers on, so maybe one of them has been changed, I don't know. And then this little circuit here is that comes out of there. Then go up to this one. Simple as that. So that is basically a 6 amp breaker, which then goes up and feeds this photo cell, which then in turn comes back out and goes to this constant current LED driver, which turns the LEDs on the top. So yeah, that is that is something super simple, but that is basically how one of these works. They then go through the contactors, which are monitored by the controllers. If the car's plugged in but not asking for a charge, that's going to know it's not going to let the contactor through. It's also going to monitor the DC and use that to make its mind up on certain things. And that is basically how the controller works. All the brains are in there, but the way it tells it to come on and off basically is just by a contactor. So yeah, pretty simple. Obviously I've explained it like a complete layman electrician. Any electrical engineer will probably be cringing, an EV charger engineer, but yeah, that's basically it as I see it anyway. Let's start stripping these out and changing them over, and then we can start testing this bad boy as well and seeing how it holds up. So I'm just going to grab a photo, because that's basically the easiest way. If you're ever taking something apart and you're not 100% comfortable, then just always grab a photo. I'm going to have to cut this one out. Yeah, the terminal's completely melted inside, so there's no chance of me ever getting that out again. We then got the PP and the CP cables, so we'll get them out the way. They again go into the bottom of that controller, to the brain. And then we've got our earth. There we go, so that's those out the way. Oh, okay, yeah, so that is just a locking mechanism basically. So when the charger's on, little coil energizers in there, pushes this lock down, and then you obviously can't remove the plug while it's in use. So that is a lot simpler than I thought it was basically. I really do need to invest a bit more time into EV really, but I know enough. I've got my guidance notes with me and stuff to get this all tested up and compliant, but It's just one of my weaker areas for sure, as an electrician. Now I've loosened it off a bit. Yeah, there we go. Yeah, I can get that off. Right, so this should come off the back. There we go. Get more into that in a sec. So this needs to go back on. It's basically just a vanity plate or decorative plate. That's a new one. It's actually got washers and stuff, so it's quite interesting because the other one didn't. Like I say, nothing wrong with that, but we'll change it anyway. And then this is the old one, so you can see that pin that's completely burnt out there, and then that terminal there as well. I had to cut it off because yeah, it's just completely melted. Got our cable as well, seized in there. But yeah, it's like that on all three of them, so it must have been a serious fault with the charging lead, and it just goes to show you, like, EV, man, is it's easy for it to go south pretty quickly. So these have got far better. These have got gaskets either side now. So yeah, it's like double gasketed, got washers on, so these are definitely better than the ones provided before. Just having a look. The terminals look better as well. Slot it in. Make sure the gasket's on there nicely, which it is. Let's just get one on loosely. I ain't got to worry about the thing falling off then. I want to go tight, but I don't want to go mad because I don't want to stress the gasket out too much. You can easily overdo it. Okay. So that's our new socket housed. Lovely. Right, that's not going nowhere. Cool. It's not obstructed or anything. We'll test that out with our functional tests anyway. Cool, and then we've got to get this live in, but I'm definitely going to need to free up some slack. There we go. Should be plenty, and then I want to at least take off from the visual damage that much. Let's just see how the coppers fare in there. It could be a little bit more. How much I've got to play with? Plenty. So let's go a little bit more to be safe. Strip these. Yeah, copper's nice and bright there. You can see, well, you can't because I've just thrown it away. But on the old one anyway, you can see the coppers. It's all like, I think it's oxidization, is it, when it goes green and stuff. So yeah, it's in a bad way there obviously. But now we're down to some nice bright wire. So that'll be perfect once I can get a ferrule on it. This is my crimping and connectors pack out. I really do need to do a complete pack out tour. This is available on loadout soon as well, so that's exciting. But yeah, we just won 6s, I believe. Pretty sure that's 6. So these are the right ones, and then I'm going to be using the SWA ferrule crimper just because it gets the job done. I've got the mandrill ones, different style ones, but yeah, I love these. SWA actually sent me these, so shout out to them. But yeah, they've lasted 2 years, 2-3 years. I think I got sent them during the first lockdowns of 2020 actually, so yeah, they've done well. I recommend them. There's a margin for error if you pick the wrong terminal, but as long as you check and check again, they're pretty sweet. So I just want to slide these on. Actually want a bit more copper exposed. There we go. That's it. You can trim the rest off afterwards. Just want to make sure I pick the right terminal. Get in there nice, big squeeze. ferrule done. And then just want to trim the rest of this off, this excess. Go. You can see there, that's got very hot. Very, very hot. There we go. Wash up and that is those two changed. Pretty straightforward, but I know you guys find this sort of stuff interesting. Basically, it's what made the channel, me taking things apart, back together. I waffle as well a lot, and in edits and stuff, I'm constantly worried about whether I'm waffling too much or, yeah, you know, if it's boring. A lot of people reassure me in the comments that they like hearing my mad ramblings, because I guess it's sort of like a step-by-step of like how I'm doing it or whatever, but to me it's just, well, it's just work, so it's weird in that respect, I guess. But I'm actually more excited for the testing, to be honest. I get to play with that new tester, and yeah, it's something I haven't really done a lot of on the channel or in general, so yeah, that should be good. What I'm going to do now is get the other one smashed out. I think I'm going to try and film like a YouTube short, Instagram reel doing the other one. So that means I won't be filming it, plus you've already seen it, to be fair. But yeah, then I'll be able to catch up with you guys on the testing. So, first of all, I just want to see if I've actually got power. Yeah, 230. I can turn my RCDs on. That will start initialising everything, but I just want to press the test button. So these Rolex ones, a bit like the old MK ones, once they trip, they sit in a middle position. You actually have to push them down to fully off before you can turn them back on again. As far as the test button's concerned, they're working correctly. Obviously, we're going to do a proper RCD test to confirm if they're sweet, but so far it's looking okay. So now we're going to run through the sequence of tests. Now this differs for depending on the type of charger, whether it's three phase or not, but I'm just going to run through the sequence as far as I'm aware with a single phase charger. So you want to start off with your dead test basically. So you want to do a continuity of CPC and an insulation resistance test. Now this place has recently had a EICR and the circuits have been validated as satisfactory, and I haven't touched anything before this, so I'm not going to do that today just because it's unnecessary, and we're just doing some testing to prove what we've done is sound, and everything I've done has been within the charger. I am going to do a ZS test, I am going to do an RCD test. Phase sequencing would be important, but again, not applicable. Yeah, RCD and ZS test. ZS will confirm that the circuit's satisfactory anyway. I'll check that against the breaker, and then I'm going to rely on the EICR for the insulation resistance and the R1, R2 values. So then you want to get into your functional tests, the different charge states. You want to plug it in, make sure it cycles through those, protective earth error and your CP error, make sure that knocks off. You want to make sure it locks, so where I've refitted those locks to the sockets, you want to make sure it locks them. And then obviously if there's any specific tests based on the charger, you know, if it had a kiosk or something, you might want to functionally check that the kiosk activates the charger, etc. Obviously this one's quite basic, but I will run through the different modes. We'll start with basically the electrical tests, and then we'll move on to the functional ones. Like I said, I'm not going to do R1, R2 or continuity of CPC, and I'm not going to do insulation resistance, so we're going to fast forward straight to Zeddy. I've got my EVSE adapter plugged in. I've then got it set to 32 amps, and I've got it set to A, which is open. And then coming out the back, I've got my plug top, which then goes into my into my QTech KT66DL. So there's a lot going on. Now by doing this, we're actually going to do some functional testing by default, but I'm just going to glaze over it here and then run through the functional tests afterwards, just to yeah, make it clear for you guys basically. I'm going to bang it onto C, which is charging no fan. This unit doesn't have a fan, so yeah, charging no fan. That's then going to allow current to pass through. I then want to turn this on, free lead, cool. Then I'm going to press test. It's going to take a little while, and it's 0.49. So I'm just going to make a mental note of that, and then I'm going to jump over to RCD testing. So we're going to do it on auto. I'm hoping auto displays the DC results as well. Type A. Oh, and then EV will provide that result as well. Okay, let's do that then. Let's press test. Cool. Right, so that's tripped off. Not the RCD though. It's doing it all via. So doing it all via the controller module, and that's because it was DC. So it's done the 2 DC tests first, which is managed by the controller module and there, and now it's doing the 30 milliamp AC, which is also being controlled, okay, by the contactor and the controller. And that must obviously, I mean, it's a type A RCD, so it's providing that protection, but there just must be selectivity between this device and that device, or that device and that device, which means this actually ends up doing all the work, and this is just there as secondary. But it's definitely our minimum focus distance. Sorry, it's definitely type A though. It's double pole. Maybe you need this for the double pole and to satisfy, yeah, that sort of device, that device requirement, and then this is obviously far smarter, but maybe doesn't satisfy the device requirement. I don't know. That's not going to pull out actually, which is good. Oh no, it is. Okay, so that's something we need to look into, because that shouldn't allow you to do that if it was on and charging. So yeah, we'll cover that in the functional tests. But yeah, let's flick that into A, because we don't want that coming on whilst we're messing around. Excuse the bad camera work. There we go. That's in. I can then flick that. Again, we've got operation of that contactor there, so we know that's sweet. Let's just do a loop test again. Completely not necessary now, but why not? May as well do it while we're here. Cool, 0.44, so I'll keep 0.49 because it's the highest. Then I'm going to go back onto RCD, type EV, auto, press test. It's going to run through the different cycles. DC first at 0 and 180. There we go. Okay. Nothing at half times. 0 degrees, nothing at half times 180. That's what you would expect. It's now doing 1 times. It's tripped. It's now doing 1 times at 180. Again, tripped. It's now doing 5 times. It's going a lot quicker. Cool, so that's sort of a test. One of my favourite things about this is how it displays them all, to be fair. Dead handy that. You can get a quick photo of that, fill out the paperwork later, but yeah, you've got all the info there. But again, that was all done by the mode 3 controller controlling the contactor and obviously the residual current relay. This RCD again did nothing, which is interesting. Very interesting. I mean, I'm tempted to run some tests on this separately with the, you know, without the without the mode 3 controller, and just see how it operates, and if there is some sort of selectivity there. But Yeah. Right, so I just made a quick phone call actually because there was a couple of unanswered questions that were eating away at me. One, why have you got a controller which has AC and DC RCD protection built into it, controlling a contactor, and then you've also got a 61009 RCD in front of it? Just seems like two of the same devices, a bit baffling. And two, what is the maximum disconnection time for a DC RCD? So I rang up Craig, Top Beaver. Craig Buist, works at Burgess. He was actually in the videos with the college as well, with Waltham Forest College. Basically, what he says is the circuit board or controller RCDs are not recognised by the regulations because they're not upheld to a standard like a 61009 is or a 61008 or whatever. Yeah, they have to put in the type A double pole as well, RCD in, even though they're not basically going to use it. It might be used in some, rare circumstances, but then they put their controller in, which provides again DC and AC RCD protection, as well as all the smart other stuff, and they rely on that one, and they must set the thresholds a little bit more sensitive. So obviously you've got selectivity between their controller or their RCD and the RCD next to it. So this one is set up to be more sensitive than this one, because they actually rely on this, and this provides everything and more than this one does, but this one isn't recognised by the regs and this one is. So to comply, they have to fit both. It's funny as well because I've obviously tested through the socket and I've tested this one, but it's just interesting because if this isn't recognised by the regs, should I be testing this one? But then I need to plug in through here and this one's before it. So yeah, it's just interesting. There's always a lot of debate and stuff with EV, but yeah, that is that question answered anyway. Nice one, Craig, Top Beaver. The second question was these results. So here you can see I've got 402 and 410 milliseconds on the 6 milliamp DC. Obviously it's 0.4 of a second for an AC RCD for final circuit, so I was just interested because it seemed a little bit high, and I knew the AC results were fine, but I weren't sure about the DC. So I rang Craig and he sent me a picture of the table, and basically, yeah, circuits up to 230 volts to earth with a UO of 230 volts, it's 1 second for DC. Between 230 and 400 it's 0.4, and above 400 it's 0.1. So for 230 we were actually in because it's just under 1 second and we're 0.4 of a second. But if this was three phase, yeah, it would just marginally fail, but obviously it doesn't really matter because this is single phase, and if it was three phase it might have a different device in anyway. But yeah, interesting. Sorry for the waffle, but I had the burning questions. I'm sure you might have too. Now we've got the answers to them. But yeah, now let's run through our functional tests. The first functional test is, well, first I want to do my PE test again. Cool. And I just want to go through the charge states. So A is open. So basically nothing should be happening because it's open, it's not charging, there's nothing in there. And yeah, all the contactors are off and it's in a dead sort of state. Then we want to go to B, which is on but not charging. So it's plugged in but it's not charging. For instance, if the car is done charging basically, and again the contactors have not energized, there are some lights on. You can see the LED there is on. There's no voltage or current passing through into the car. And then I've just flicked it onto C, which is charging, no fan. This doesn't have a fan basically, so we don't need to do the fan mode, which is D. And the contactors popped on, so I can see when I go between on, not charging, and then on, that contactor is popping in and out, which is just what we want it to do, like that. So we're happy with that. Charging states we're happy with. I'm then going to leave it in an on position, and first of all I'm going to press PE error, which should simulate an earth fault, and that is just tripped. Yeah, it's pretty instantaneous. So I press the button, it's off, I let go of the button, it comes back on. And then CP error, which is a communication error. Again, I press that button, that simulates a communication error. Yeah, that is working. So the communication and the PE errors are, it registers that and it turns off the device. I've also got red in L1, So that's quite cool. Let me know that L1's live. Now we want to leave it on and we want to try and pull it out, and we can. So there's an issue there. There's an issue there with those, so I'm actually going to look into that. So it turns out I've just been being a bit of a wally, and I didn't have the lead quite in properly. I think either too far or not too far, but basically it's in an open state. It's now on without charging, and you can see the electromagnets pulled the locking mechanism in, and then when we go into a charging state as well, it remains locked. So yeah, pretty smart. That works. I'll just check the other one. Sweet, other one's working fine as well. Yeah, that is your functional test done. Like I say, if there's a kiosk or something, or any other inherent functionality to the device itself that's not common across all EV chargers, you of course functionally test that. But that is pretty much it. That is, yeah, the socket's changed, my relevant live test done, and all of the functional tests. So yeah, pretty cool. It's been an interesting video for me to make. I've really enjoyed making it. Actually, it's something different. I've learned a lot, and I love messing around with controls and stuff like that as well, trying to figure out how they work and that, and hopefully bringing you guys along for the ride. It's been interesting for you too. Apologies for the bad camera angles, shaky footage, anything like that. Like I said, I'm running solo today, vlog style, but yeah, regardless, like I said, I've enjoyed making it, and hopefully you've enjoyed watching it. Thanks for watching as always. I'll catch you guys on the next one.